This is a continuation of section 3.2 lecture, and I cut the other one off because I wrote the problem down wrong. So I just wanted to make a new video with me working through a problem without writing it down incorrectly. So let's look at, this is section 3.2, problem number 2. We're just going to look at this problem just so you have an example. All the homework problems are really similar for this section. It's a really short homework section, and you're doing the same thing for each problem. And I wrote the problem down. I wrote it down correctly. And I just want you to notice for the first part, it's asking you to find the average or mean slope of the function on this interval. And it's basically, when it's asking you for the average or mean slope, it's just asking you for the slope. It's that same regular old slope formula, average rate of change, y2 minus y1 over x2 minus x1. So that's the first part of the problem, just asking you to find that. So we'll go ahead and find that. So again, I want to point out that average or mean slope that they call it, it's just the slope of the line. So it's just using this formula right here, the formula on the right, which is the same as your regular old slope formula. It's y2 minus y1 over x2 minus x1, right? It's just written f of b minus f of a, that's your y2 minus y1, over b minus a, your x2 minus x1. So you can think of your a and b as 2 and 10. And then your f of a will be f of 2, and plugging in 2 for x into the function that we're given, 1 over x, we get 1 over 2. And then f of b is f of 10, and so that's 1 over 10. So if we use our slope formula, f of b minus f of a over b minus a, we get, we have f of, what was it, 10 minus f of 2 over 10 minus 2, which is 1 over 10 minus 1 over 2 over 10 minus 2 is just 8, right? And then from here, I'm going to give myself some room. I'm going to continue this over here just to give myself some room. So I have 1 over 10 minus 1 over 2 all over 8. And you have options as to how you simplify this. I'm going to simplify this the way I've been simplifying these types of expressions in class. This is a complex fraction. And one way that you can simplify these is to multiply by the denominators, 10 and 2. And so I'm multiplying both my numerator and my denominator by that 10 and that 2. And then, so I'm going to distribute all of this. And when I distribute all of that, I end up with 1 over 10 times 10 times 2 minus 1 over 2 times 10 times 2 all over 8 times 10 times 2. And I end up, so the reason I like this method is I end up canceling out my fractions. And so I no longer have complex fractions. So like the 10 gets canceled here. So all I'm left with is a 2 times 1, which is just 2. And then for my second fraction, the 2's cancel. So all I'm left with there is a 10 times 1, which is just 10. And then my denominator, I just have 8 times 10 times 2. And 2 minus 10 is -8. -8 over 8 times 10 times 2. And the 8's cancel, right? So I'm just left with -1 over 10 times 2, which is 20. And this is my answer for the first part of the problem, where it's just asking us for the slope. So that's one way to simplify it. If you prefer to just combine your fractions, like 1 over 10 minus 1 over 2, like get a common denominator, combine those, and then simplify, that works also. So just do whatever feels more comfortable to you. I'm just doing it the way I've kind of been simplifying these complex fractions since the beginning of the semester. So let's see, I get -1 over 20 for that. And then the second part of the problem says, by the mean value theorem, we know there exists a C in the open interval 210 such that f prime of C is equal to this number, -1 over 20. And then they ask us to find that C. So like right now, what we just did is we found basically like the first part of the I should say the right side of this equation in the mean value theorem, the purple. And now they're asking us to find the blue, the slope of the tangent line, the derivative, and find out when that's equal to the purple. So I'm going to find the derivative of my f of x. So again, my f of x was 1 over x. This was the original function that we were given. And so now I will find my f prime of x. Well, I know this is just -1 over x squared. I just have that memorized because it comes up often enough that I just memorized it. But this comes from this rule from algebra that a to the -m is 1 over a to the m. So if we have 1 over x, I can write this as x raised to the, because x in the denominator is raised to the power of 1, I can rewrite this as x to the -1. This is x to the -1. So then when I find my derivative, I use the power rule. So this -1 comes to the front, and then I take 1 away from my power, and I end up with -1x to the -2, which again, using the box rule from algebra in red, I can rewrite this as -1 over x squared. So that's how I get my f prime of x is -1 over x squared. And this is the left side of that mean value theorem. Like this is the f prime of c part. And so what I want is to find out when it is that this is equal to this, the f of b minus f of a over b minus a. And you know what, I should actually replace this x squared with the c squared, just to be really true to the theorem, right? Because it says f prime of c equals f of b minus f of a over b minus a. So I'm going to solve this equation, -1 over c squared equals -1 over 20. And I think I'll cross multiply, which is really just multiplying both sides by the denominator. Really, that's what you're doing when you cross multiply. I am going to include the negative with the 1, if that makes any sense. So cross multiplying, I get -1 times 20 equals -1 times c squared, which is the same thing you'll get if you multiply both sides by the denominators. If you multiply both sides by 20c squared, that's what you'll get. What I just wrote. And cross multiplying is just a shortcut for that. Multiplying, here, I'll show you. I just want to make sure you understand how we get that. So anytime you have an equation with fractions, you can get rid of the fractions by multiplying both sides by the denominators. And that'll get rid of the fractions for you. So like notice on the right side, the 20s cancel out and I'm left with just -1c squared. And then on the left side, the c squares cancel out and I'm left with 20 times -1. Same thing I have on the left over here. I just cross multiplied, so I got that in a shortcut way. So I end up with -20 equals -1c squared. I'm trying to get c, so I'm gonna divide both sides by -1. So these -1s cancel, and I end up with +20 equals c squared. And then to get c by itself, I'll take the square root of both sides. So square root and plus or minus square root. And I end up with c equals plus or minus the square root of 20. Or 2√5 if you want to simplify that. And oh, it says it has to be in the interval 2, 10. So we're only going to put the positive square root here because that's the only number that's between 2 and 10. The -√20 is not between 2 and 10. And I'll just say, so √20 is in this interval 2, 10. -√20 is not. So that's why we did not include the -√20. And then one other thing I just want to say is that it is really common to simplify a square root like this. So recognizing that 20 is the same thing as 4 times 5. And so a lot of people would go on not to do what I just did, but to do this and then take the square root of 4, since 4 is a perfect square. And so you could also write your answer like this. So c equals 2√5. Or c equals √20. But the 2√5 is actually the more common way that people would write it, because that's the simplified way, even though it doesn't look more simple. So anyway, I hope you are able to do this homework, but if you struggle, have any questions, email me or message me on Canvas or come to a work session. Take care. Bye.